Chemistry is a science of materials and molecules. Here in NTU Chemistry, we have a whole range of research activities on all things molecular. From the basic understanding on what a molecular chemical bond is, to the manipulation and control of atoms and molecules to make new materials of use to mankind. I shall let some of my colleagues tell you more about the amazing stuff that they do here in NTU Chemistry.
Our research group is interested in the synthesis of natural products having unique properties for useful applications, such as medicinal applications. For example, here you see a model of the structure called fasciclovine, which we recently succeeded in synthesizing artificially by chemical synthesis. This molecule is of much interest to biologists as it is involved in biological processes which may tell us more about how certain anti-cancer drugs work. The natural sources of fasciclovine are extremely limited, and thus supply of this molecule by organic synthesis can greatly help biologists. Another real motivation for us to synthesize this molecule is its unique and elegant structures. Very beautiful, don't you think so?
In our labs, we are interested in using chemistry to solve current and future problems. One of these problems that chemists are uniquely qualified to solve is global warming. We are trying to develop ways to mimic how green plants capture solar energy and convert CO2 into energetic molecules. We develop catalysts based on earth-abundant components such as nickel, complexes, and copper dyes, and study these reactions so that we can create what are known as artificial photosynthetic systems.
The fundamental processes in chemistry, such as bond breaking and forming, bond vibrations and electron motion within molecules happens in a timescale of femtoseconds. That is 10 to the power of negative 15 seconds. The only way to catch these molecules in action is to build a camera with ultra-fast shutters. What you see here is an ultra-fast laser system which creates laser pulses that are only a few femtoseconds long, and they act as shutters of an ultra-fast camera. Using this, we are able to capture electrons moving around in molecules and materials.
Welcome to our nanochemistry lab. Here we develop techniques to synthesize nanometer-sized materials of all sorts of shapes and functions. Have you heard of 3D printing? In our lab, we do 3D printing as well, but at the nanometer length scale. Come, let me show you. Over here, what you see is our nano 3D printing. It is currently making nanostructures of 200 nanometer in sizes. To give you an idea, these structures are actually 200 times smaller than the width of our hair. So can we use these beautiful structures for real-life application? In fact, in our lab, we use them for anti-counterfeiting application. These structures are chemically coded with molecular information, which can only be selectively read out by using advanced spectroscopic technique. In this way, these chemically coded nanostructures can be used as security labels to deter forgery.
Analytical chemistry is the science behind the collection of chemicals and the analysis of substances to determine their composition. And we have a special machine over here that is used for collecting air samples. This machine is used for especially collecting particles that are present in the air, which is especially problematic during the haze pollution. So we brought our sample downstairs from the instrument. We chop it up into small pieces, dissolve it in acid solution in the microwave digester. We then take the dissolved sample and inject it into the atomic absorption spectrometer, and that gives us the metal composition to know what pollution levels exist in Singapore.